Okay, so before we do an example, I just want to finish up a couple thoughts about how this ratio test works. I did tell you in the last video that if the limit is 1, the test is inconclusive. If the limit is bigger than 1, oops, I've been writing 1 out, so I may as well do that again. The series diverges. And I think this is the sort of thing that you've learned in the past, but I feel like using this test can still be a little bit like confusing to people. So I just want to make sure that we're clear on the steps to do it. So to find radius of convergence, calculate x minus a, the limit as n goes to infinity, cn plus 1 over cn. So just calculate this thing right here. Then solve for values of x so that that amount is less than 1. So kind of what that's going to look like is so if you compute this limit and you get some number L, then what you want is just absolute value x minus a times L is less than 1. So that means you just want absolute value x minus a is less than 1 over L. And that right there is going to be your radius of convergence. And so I'm going to go ahead and do an example that kind of shows how this works. I didn't write down what it came from in the book. Sorry about that. But it goes from n equals 1 to infinity. We're looking at x minus 3 to the nth power over 2 to the n times n. And we're going to talk about what the interval and radius of convergence are for this problem. So kind of looking at this form, first we just want to be clear about what all the notation means. So our infinite series, to make it look more like the way that I've been writing them, we could write like this, where here's our Cn, there's our a, and then here's our like x minus a to the n right there. So what I'm interested in is the limit as n goes to infinity of subsequent terms. So we've got that like x minus 3 to the n plus 1 over 2 to the n plus 1 times n plus 1 over x minus 3 to the n over 2 to the n times n. And what this is going to turn into is having this x minus 3 out front, limit as n goes to infinity of the ratio of the coefficient part only. So 1 over 2 to the n plus 1 times n plus 1. Oh, I don't have enough room for that. Okay, ratio as 1 over 2 to the n plus 1 times n plus 1 over 2 to the n times n. Sorry, 1 over 2 to the n times n. So here is where I wrote that simplification before. So your x minus a terms, I told you they cancel out with each other. Here's x minus 3 to the n plus 1 divided by x minus 3 to the n. So those n's cancel out. Just give me a single x minus 3 that I pulled out right there. And then when I wrote down the general form, I just said you look at Cn plus 1 over Cn. So here we are. This was our Cn. So here's Cn plus 1, 1 over 2 to the n plus 1 times n plus 1. Here's Cn, 1 over 2 to the n times n. Sorry if I'm saying things that are really clear to you, but I just worry about how confusing series can be because they tend to be smashed into the end of a bunch of different sections as you go through different math classes. So let's kind of like think about algebra to start simplifying this. We can just ignore this x minus 3 for now. Let's not even think about the fact that we're eventually going to have to take a limit. Let's just see sort of what this all looks like. So I'm going to rearrange, instead of having 1 over in the numerator and 1 over in the denominator, I'm going to go ahead and say, okay, 1 over in the numerator means I just have that term in the denominator. 1 over in the denominator means I just have that term in the numerator. And then I can see that the same way my x's canceled out before, now I have these 2 to the n's are going to cancel out. So my n's going to be left the same and my n plus 1 is going to be left the same. But now I just have sort of a 1/2 right there. And then from here, if you wanted to, you could go ahead. Oops. Actually, I don't want that to be a fraction. So you could go ahead and say, okay, well, that 1/2 comes out for sure. Doesn't really do anything. And then I'm just looking at this ratio between n and n plus 1. So let's pull my 1/2 out of the limit because there's no n in it anymore. I'm just looking at the limit as n goes to infinity of n over n plus 1, the absolute value of that. And then here you would have to use like a limit property that should be familiar from calculus. You could have taken this one enough times that you know it's just 1. If not, you could just go ahead and take the derivatives and you end up with 1 over 1. And so in either case, that limit is just 1. Okay, so real quick, I just want to stop, talk about where we're at. When I said we're thinking about a radius of convergence problem, first thing we do is calculate this limit. That's what we did just now. We calculated that limit. We got to this point. We have x minus 3 times 1/2 times 1. And so this right here is that thing that I called L on the last page. Right there. Limit of n going to infinity of Cn plus 1 over Cn. That's capital L. And so at the end, you have this thing that's x minus a times L. And the thing we want to check is what values x give us convergence. So we want to know when this quantity we just computed, x minus 3 times 1/2, is less than 1. If that amount is less than 1, we know that we have convergence. Or x minus 3, absolute value of that is less than 2, because I just moved my 1/2 over. Multiply by 2 to cancel out the half on both sides. So right here, this tells me the radius of convergence. I told you 1 over L gives you the radius of convergence. Now we have 1 over 1/2 gives us 2, radius of convergence. So radius of convergence is 2. If we want the interval of convergence, then we just sort of have to expand this into an interval. So you'd say minus 2 is less than x minus 3 is less than 2, or minus 2 plus 3 is less than x is less than 2 plus 3. So that just gives you 1 is less than x is less than 5. So that part is just kind of algebra. And if you want to use like bracket or parentheses notation, that's just open parentheses 1 to 5. All right, so that's convergence. Sorry these videos ran long. Convergence, I think, is kind of a sticking point for people. We'll move on to other properties of series in the next video.